Over here. Mm-hmm.
Did you text Luke or Fred? I'll do it.
No worries. No worries.
I appreciate it.
Okay. Yep. So I'm Heather Rosentrader. I don't know if you want me to spell at least my last name. It's Rosentrater. I'm the Senior Vice President of Energy Delivery and Shared Services here. So thank you for coming. We continue to experience unprecedented heat on our service territory, and we, based on a combination of that heat as well as unprecedented demand, we've experienced constraints on our system. We do plan for these situations, and saw yesterday that the record heat and a combination of that with the high demand caused unexpected constraints on our system. I think this might be a good time to help clarify that this is a distribution constraint issue. It's not a supply side. When people hear about rolling outages, I think they think about those that they've heard about maybe in California or even in Texas, and have seen those be spread across broad areas in their system, and that can help alleviate when you have supply issues. You can spread those outages out more fully across the system. When you have distribution constraints, unfortunately, they're where they are on the system. You can't change where the outages are occurring to help reduce those constraints. They're in certain geographic areas based on the equipment that is constrained, and so that's why we haven't been able to spread where those outages are occurring across different customers. We did experience about, at one time, a peak of about 9,300 customers yesterday that were out of power, and a total, because we were able to get customers back on before others were taken out, it was a total of about 24,000 customers that experienced an outage yesterday. The customers that have been communicated to today, this morning we sent a proactive notification to about 21,000 customers, sharing that they could experience an outage sometime between, for the most part, between noon and 8 o'clock today. So I thought it also might be helpful to just share a little bit of information about our distribution system and our infrastructure. So you've heard terms like substations and distribution. The substations are the heart of our system. You can see them that way. It's where we collect the energy from the generation, goes to the substations to be lowered in voltage, to be distributed to neighborhoods. So again, the substations are like the heart, and so we really have to protect them, because if they are damaged, then that can cause significant issues for the neighborhoods that they serve, more long-term issues. And so that's why we did proactively turn off the power once we got alerts that the equipment was nearing that that could cause long-term damage. And then when I talk about circuits, those are like the arteries that come out of the heart. Those are the conductors, the wires that you see that serve the neighborhoods. So we have had some constraints on those, the equipment that's in the substation, and we have had some issues on the feeders or circuits that serve the neighborhood.
Are these issues with like equipment potentially overheating? What are some of the issues where you have to make that call to cut them off?
Yes, absolutely. So normally, and this is where, we planned, we knew that the forecast was sharing these record high temperatures. We were planning, rearranging the system to accommodate for that. And in some of the system and some of the infrastructure, it hit those temperature alarms before it hit the capacity. So we were planning based on the rated capacity of the equipment, and some of the equipment wasn't able to operate up to its rated capacity. And that's in some degree why it was unexpected, as well as the demand just increasing so quickly. We did have set a peak yesterday and expect to set another system customer usage peak today.
Why exactly are more geographic areas more stressed than others? Is it the age of the equipment, or is it just there's more people there?
Yes, so we've experienced both actually. We have had 4 transformers that had issues yesterday, 4 of those substations that had issues, and 2 of them were alerted based on that that temperature alarm that would be a signal that it was based on age, that it wasn't able to meet the run at the capacity it was rated for. And we had 2 areas that are up north that are more of our high growth areas that had just much higher demand based on the temperatures than we expected.
Can you quantify, I guess, just how much you hit that threshold versus like a typical summer day, I guess, in like number terms, I guess, for people?
So let's see, versus an average summer day. I mean, I would say it was versus what we normally design for, it was probably about 30% higher than what we normally design for. We designed the system to actually have additional capacity to be able to back up adjacent areas. So if you do have an outage in one area, that the next area that's closest to it, you can do what we call switching, and you can take up some of that load. So we actually plan to have additional capacity on the system to be able to support adjacent areas when they have issues. So we normally have significant additional capacity to handle those kinds of situations. So you can see that a day that we're using up all of that additional capacity and then some is a really extreme situation compared to how we normally operate.
Was it 30% higher than the extra you already planned for?
So we hit a new system peak, and there's some details to that aren't completely reflective, because the new system peak that we had was, I think it would have been, if we hadn't had to proactively cut off customers, it would have been several hundred megawatts higher. So about 2,300 was our previous system peak. We probably would have hit 24 or 2,500 if we hadn't had to proactively reduce customer usage. And some of that previous peak actually happened years ago when we had some larger loads that are no longer there. So those loads have been distributed across all of these existing circuits, and then you have that additional load on top of the incremental system load that was distributed across those.
What was the reason why customers weren't informed beforehand yesterday?
Right.
I never really got why that was.
Yes, absolutely. Our planning efforts identified that based on where we thought that the load would be and where we thought the infrastructure capacity would be based on the rating of the equipment, that it could handle the forecasted load. And the load was higher than expected. Some of our infrastructure wasn't operate as expected, and it came more quickly than expected. So initially, again, when we were planning, we did some switching to try to balance the circuits, and felt that based on our forecasts, the system could handle what was there, and had a plan for if if it was getting close to some of those capacity limits, then that we could proactively notify customers. But we weren't expecting that there would be outages. But we had a plan in place, and again, things just happened so much more quickly than we expected that we weren't able to provide those proactive notifications.
On the distribution system, sorry, were there other additional locations that also had power outages? I know Emerson Garfield had some power outages today, something they weren't expecting that wasn't a part of the list you guys gave yesterday.
Due to the weather issues, I'm trying to think of today, we haven't taken outages anywhere that customers weren't communicated to this morning. Of the 21,000 customers that were communicated to, we haven't taken any of those planned outages outside of those customers.
We've heard from multiple people today that are experiencing outages that they didn't get that notification. Why could that be?
It could be that their contact information isn't up to date. So I would encourage, customers to go into the system, really make sure that their phone numbers are up to date, that their email addresses are up to date, and we'll continue to try to provide information through other outlets in terms of the locations of those potential outages. But they are based on, how our circuits run, and so the best way for them to know whether they would be part of those outages is to make sure that their contact information is up to date so that they get those proactive notifications.
And have you guys experienced any unexpected outages today?
Outside of, I don't know, I haven't looked. We have about 2,400 customers out right now, but the majority of them are part of that group that was communicated to this morning. I think we had, on any given day, we could have several thousand customers out, again, just due to car hit poles, other issues that occur on our system. So that kind of stuff is still occurring.
And could you elaborate a little more on the specific areas of Spokane that are getting hit the hardest on the system?
Yes, we have that list, and I don't have it memorized, so we'll bring Casey in to help with that.
So the customers that are impacted in Spokane, it's primarily in Spokane. So we have
Yes.
Northeast Spokane, parts of Northwest Spokane, north near Fairwood, 5 Mile. Parts of the South Hill were impacted yesterday, and we have some that are expected in Spokane Valley near Barker.
And then we do have one small area in Lewiston that's been identified, but it is mostly in the Spokane area, mostly up north. We've been doing some work on the system to continue to try to minimize what outages would be experienced the rest of this week, and to continue to improve that prior notification process, as well as give more certainty for customers about when those outages would actually occur.
And you said that customers would experience an hour of blackouts, but Eagle Ridge has been out today for over 2 hours. Can you explain what's going on there?
We can check specifically.
Yeah, we can
on
check
Eagle
specifically
Ridge.
on Eagle Ridge.
Can you speak to target that we're looking at with that hour range?
Right. So the plan that we implemented from yesterday, and you shared accurately, was to move today to get to proactive notification, at least with a range. Where again, we're trying to move tomorrow to get even a smaller range for customers to know when that outage might occur, and then to coordinate sections of those constrained areas to be able to limit the outage that any one customer is experiencing to an hour at a time, and to rotate through those. So that is, and then we're also, so we have the broader communication today. We're putting a plan in place to also have a secondary notification once we know that the conditions are such that we'll need to take action. We're appreciating, customers' conservation efforts. We don't know exactly how that will impact our ability to minimize those outages. So that's one of the reasons why we didn't have clarity on when the outage might occur, because we want to take advantage of the conservation and push out the need for that outage as long as possible.
Okay. And the last time we saw scorching temperatures like this was back in 2015.
Yep.
But we didn't have a rolling blackout then. Can you speak to why it's happening now versus then?
Right. So there has been a lot of growth since 2015, and when and this prolonged outage or the prolonged heat that we're experiencing is different than what we've experienced previously. So it's that combination of the duration of the really high temperatures as well as the growth that we all know that the area is really growing, and so that growth has occurred in the last 6 years.
Do you have any specifics on how much it's grown since the last 6 years?
That's a good question. I think we can follow up with you on that.
And then, do you know how many days that we are probably going to be? Is it just until the heat wave has dissipated, or is it just a couple of days that this be needed?
So what we experience is usually challenges during the work week is when we have the biggest issues on the system. And so we're asking people to continue to conserve through the end of the week and setting an expectation that we could need to continue to initiate these outages through the end of the week. And again, we'll continue to improve the process to reduce the number of customers that will experience them, give them more certainty about the time they're experiencing, and work on making sure it is just an hour that they're experiencing them.
I know we talked about the equipment sort of having issues potentially with overheating and aging in these specific areas with these feeder stations, but for folks who are just hearing about these outages and going, gosh, it's during the hottest part of the day, why are you doing it then? Can you just speak to those folks about why that is? Right.
So our equipment, so the heat causes two issues that cause constraints on with our equipment. So one, the heat, as customers know, they're using more energy. So that puts more burden on our infrastructure. And then the heat as well causes our equipment to be derated. And so we already have that derating based on temperature included in the information that we watch in terms of how the system can be loaded. And again, it was derated even further than we expected or how it was originally designed.
Yesterday you mentioned part of the reason was also the fact that this is in June, that 1 hour loss. How much of a difference does that 1 hour of extra cooling time make to these particular substations that are seeing these increases?
Yes, it makes more of a difference than people would expect. Even when we are doing these smaller proactive outages, reducing that amount of load actually, even during the peak of the day, allows the transformer to cool down enough so that even when we bring that load back, it may be okay after it's had that time to cool off. So that extra hour of not having that direct sunlight, and when it's dark out, the demand, the usage that it's supplying reduces as well. So you have reduced load based on one fewer hour of sunlight, and you have just the derating that occurs based on the heat that causes more challenges than you would expect just by the 1 hour.
CAN is growing, and you mentioned infrastructure updates yesterday. Mind talking more about, will these substations be in concentration after this heat wave is over, and will we be seeing more blackout or power outages in the future, especially when it comes to winter, when people are hiking up their heating system to warm their homes?
Right. We do benefit in the winter based on the cold actually increases the rating of our equipment. So the summer has, when we get peaks in the summer, which we normally peak in the winter, it causes even more issues on the system. So the winter has different challenges, but I will tell you, yes, we are working on regularly reforecasting based on new peaks, new trends about what temperatures we need to be planning for, as well as the growth that we're experiencing on the system. So we have an entire department that is focused on doing that and taking lessons learned and new information and incorporating into those future forecasts.
When deciding when to target, do you solely base it on stress to the system, or do you have to weigh kind of residential versus commercialized areas?
Target in terms of the
Stress on the system.
So meaning the outages or the
outages.
Oh, okay. It's just the stress on the system right now. We don't have the flexibility to have any additional ability to choose where we're having these outages. It is just based on the location on the system.
And Heather, we all know that these temperatures are rising and will likely continue to do so. Will Avista pledge right now to begin the process of updating their systems to prevent this from happening again?
I would say we always have that pledge. We are very thoughtful about keeping our system up to date. Our number one priority is having reliable, safe, affordable, sustainable energy for our customers. So that's something that we have top of mind every day when we're planning our system. So I can say, yes, we pledge that, and that's been something we've been committed to.
And we've touched on growth a couple times, but as it keeps growing, I mean, is Avista systems prepared for that growth?
Right. I think we have the right support in place, the right infrastructure to build on in place. So I don't have concerns that when we have a better understanding of actual situations that we'll be able to meet that. One of the things we balance is affordability for our customers. And so if we're building more than what is necessary, then that just means more cost for our customers. So it is a part of our consideration is we don't want to overbuild. So having more information to feel more confident about what those forecasts are, give us more comfort to right size how we're designing the system.
Okay. I guess my last question would be, places like Seattle and Portland, they're also experiencing heat, but not the outages. What did they do differently than us to?
Right. I think some of what we've discussed is they just don't have the air conditioning load. I think that 1 in 3 people on the west side have air conditioning, and so that's the biggest load variability we have based on a normal temperature day and a really peak day like today, is that air conditioning load is running. Normally we can, the air conditioner kicks on and it kicks off, and so we get some diversity that reduces that overall peak by its cycling at different times for different customers. But when everyone has their air conditioning on all the time, that's what causes these really unprecedented peaks on our system.
Just about 1 more minute.
In terms of the distribution system, so it's really those particular substations in those particular areas that's the issue, not the entire distribution system.
Right, and we have, so to give a little bit of context related to that, we have about 130 substations, distribution substations on our system, and over 200 substation transformers, and so we experience issues on 4 of those. And we have about 360 of these circuits, of these arteries, and we experience where we plan today to for 9 of those that may have issues.
Thank you.
Thank you.
Mm-hmm.
Thanks so very much.
Thank you.